This lesson is an introduction to the mole and how it is related to chemistry. One of the ways to get an understanding of the mole is to consider the difference between the macroscopic and the microscopic world. In the macroscopic world, an example of an animal would be a garden variety mole. In about 1675, Leeuwenhoek, who was a Dutch lens maker, was one of the first people to be able to examine the microscopic version of animals. He used one of his lenses to look at a sample of pond water and saw that there were microorganisms present in the water. He saw that the organisms were moving around, so he knew that they were animals, so he called them animalcules, or small animals. Staying in the microscopic world, we could talk about a molecule of carbon-12. It's not really a molecule, but it helps with this analogy. It consists of 6 protons and 6 neutrons and thus weighs 12 atomic mass units. Stepping up from the microscopic and back to the macroscopic world, we see that 1 mole of carbon-12 isotope weighs exactly 12 grams. So what exactly is a mole? Let's talk about a synthesis reaction between hydrogen and bromine. If we could actually weigh out individual molecules, we would have to weigh out 4 times 10 to the minus 24th grams of hydrogen, 320 times 10 to the minus 24th grams of bromine, and 162 times 10 to the minus 24th grams worth of each HBr molecule, and we would produce that. So these numbers are kind of silly. You wouldn't be able to weigh anything quite this small. So one of the things I'm going to say is that a mole and a dozen are very similar in concept. So let's look at what a dozen molecules would weigh. So now we have slightly larger numbers, but they're still, you just can't weigh them out. So the mass of 1 mole, remember a mole and a dozen are very similar in concept. So mass of 1 mole of H2 weighs 2 grams. The mass of 1 mole of Br2 weighs 160 grams, and then a mass of 1 mole of HBr weighs 81 grams. So hopefully from all of that, you can see that the weight of a mole of one type of atom is equal to the atomic mass of that element in grams. So just some more examples. So what is the weight of 1 mole of sulfur? So if you have your periodic table handy, you can see that the atomic mass of sulfur is 32.066 AMUs. That means that the weight of 1 mole of sulfur would be 32.066 grams. Next question, what is the weight of half a mole of argon? Now, if you look at the periodic table, you can see that argon weighs about 40 AMUs, which means that if you had half a mole of argon, it would weigh about 20 grams. All right, so again, sticking with this analogy, the dozen and a mole are very similar in concept. How many dozen are there in 6 donuts? So half a dozen. So how many moles are there in 6 grams of carbon? And I picked carbon because its atomic mass is about 12, just like a dozen means 12. So that means that you have half a mole. And then how many moles are there in 1 gram of hydrogen? All right, so the atomic mass of each hydrogen atom is about 1 AMU. So that means that you only have half as much, so you have 0.5 moles. Now this next part is just a visual aid to help with the different conversions between the different quantities we're going to be talking about and moles. It's called Moletown. I'm sure there's other names for it. At the center of Moletown, we have the mole. There are different suburbs. We have Mass Mall, Particle Plaza, and Volume Villa. So let's look at what each one of these suburbs means. So Mass Mall is whenever you're talking about grams of something. And then we have Volume Villa. So this is going to be liters of of a gas at STP. At STP, we're going to talk about this some more later, but it just means that you can use this visual aid as a conversion tool. And then for particle plaza, there's a whole bunch of different types of quantities that you could be talking about. So if you want to know how many atoms or how many molecules or how many formula units you have, you will be talking about being out at particle plaza. Notice that you have these different arrows present. So what the arrows tell you is which way what you want to do with the conversion factor. So for example, if you're going from moles all the way out to grams, you're going this direction. So that means you're going to be multiplying by the GFM, which stands for gram formula mass or molar mass. If you wanted to go from liters of a gas at STP into the center of Motown, you're going in this direction. So therefore, you're going to divide by 22.4 liters. All right, so let's look at some practice problems. So the first one, what is the GFM of water? So you're just going to add up all of the molar masses of all of the components of water. So I have the formula for water. So that means we have 1 mole of water is going to be equal to 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. So I fill in the numbers. So 2 times hydrogen plus oxygen. And we get that the GFM or molar mass of water is 18.015 grams per mole. Now the next one is kind of our first numerical problem that we're going to do. It says, how much does 1 mole of water weigh? So the way you solve these problems is you look for where you have a number and a unit. So there we have 1 mole. So that means we're down here with the mole. We got 1 of them, and I'm using a mouse, so that's why it's kind of shaky. And then that gives you your starting point. Next part, you want to look at where you're trying to get to. So we're looking for how much it weighs. So that means we're trying to get to mass mole. So that means we're going to go 1 times the GFM, which is 18.015, to get how many grams. So that means that 1 mole of water weighs 18.015 grams. All right, another question. How many moles are in 22.5 grams of water? So like I said, the first thing you want to do is ask yourself, where are you starting from? So that's going to be your number and your unit. So that's our starting point. And then you have to ask yourself where we're trying to get to. So we're trying to get to moles. So we have 22.5 grams out here in mass mole. We're going to divide by the GFM, the 18.015, and that'll give us how many moles we have. So we go ahead and do the math, and we get that would be 1.25 moles of water. So the next one would be, how much would 1.15 moles of water weigh? So you should ask yourself, where am I starting from, and where am I trying to get to? So hopefully you said to yourself that I am starting from 1.5 moles. So I'm in the center of Old Town, and I'm trying to get out to mass mole. So we go ahead and write down the numbers. So we're going to multiply. One of the ways I tell people to remember whether you're going to divide or you're multiplying without having to look at the picture is that if you're starting out at the center of town at a mole and you're trying to get out to one of the suburbs, the area is getting bigger, so you're multiplying. If you're going from a suburb into the center of town, the area is getting smaller, so you're going to divide. So we end up with 22.022 grams of water. All right, so Just like a dozen of something contains 12 of those somethings, it doesn't matter what you have a dozen of. It can be a dozen eggs, it could be a dozen donuts, it could be a dozen pencils. A dozen means 12. 1 mole of something contains 6.022 times 10 to the 23rd of those somethings. So just to give you an idea of how big that number is, I believe that I read this correctly. ChatGPT says I'm wrong, but that's okay. We'll use this because it's still a very ridiculous number. If you take a mole of plain M&Ms and you layer them out on a football field and you let them stack up and they don't crush and don't fall over, you would end up with a stack of M&Ms that's 53 miles high. ChatGPT says it's out past the sun, so I got to do some more research on that one. All right, so now we're on a different part of the mole town. We have, the question is, how many molecules of water are there in 1.5 moles? So it says that we are starting from center of mole town. Oh, lost my pen. Center of mole town, right there. And we're trying to get 2 molecules. So molecules is one of the ones that's over here by particle plaza, or representative particles is actually what it means. So we're going to take our 1.5 and multiply by Avogadro's number, that's 6.022 times 10 to the 23rd, and it gives us how many molecules. So we end up with 9 times 10 to the 23rd molecules. All right, so now we have how many moles, so we're going back into the center of town, are there in 2 times 10 to the 22nd formula units of sodium chloride. So we're starting out here, particle plaza, and we're going to divide by Avogadro's number. Now, one of the things that trips people up the most is when they go to divide by Avogadro's number, there's an order of operations issue that they have with their calculators. So I would recommend always putting Avogadro's number inside parentheses so that you don't have that issue. So we do the 2 times 10 to the 22nd formula units divided by Avogadro's number, and it gives us 0.033 moles of sodium chloride. In general, representative particles are going to be huge numbers, and moles are going to be smaller numbers. I think the biggest I've ever seen for moles is on the order of 1,000, not anything like times 10 to the 22nd. All right, so the next one is how many atoms are in 2 moles of chlorine gas. So this is actually a 2-step problem. So the first one, we say that, well, we're starting out center of mole town, and we're trying to get out 2 representative particles, but we have to remember that chlorine gas is diatomic. So that means the first thing we have to find is how many molecules of diatomic chlorine do we have, and then we're going to multiply by 2 because we want to know how many atoms. So we say, all right, well, molecules of chlorine gas is going to be, we have 2 moles times Avogadro's number. That gives us 1.2 times 10 to the 24th chlorine molecules. Then we're going to multiply by 2 because there's 2 atoms per molecule. And it gives us 2.4 times 10 to the 24th atoms of chlorine. All right, so we can also use this mole town picture to convert between moles of a substance and volume of a gas at standard temperature and pressure. So what is the volume of 2 moles of hydrogen gas? So the method is the same. We're starting out with 2 moles, so we're here in the center of town. We're trying to get out 2 liters of a gas. It says it's at STP, which means that we can use this picture. If it's not at STP, we have to use a different calculation. And so we go ahead and we do multiply, and we get 44.8 liters of hydrogen gas. And then we have how many moles are there in 50 liters of helium gas at STP. So we're starting out with at 50 liters. So we're here down here in volume Villa, and we're trying to get out to moles, so we're going to divide, and we get 2.23 moles worth of helium gas.